The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thank you so much for joining us for another episode of our Best Practices webinar series with 7Signal. I see a few of you are actually already dropping in where you're joining us from. Please, if you'd like to, let us know where you're tuning in from, if you're working from home, if you're in the office. I'm actually in the 7Signal headquarters office today in Cleveland, Ohio, and I believe we have Devin joining us from Georgia. Is that correct, Devin?
Yes, lovely Georgia, raining and cold.
Sounds a lot like Cleveland, if I'm not going to lie, but awesome. We also have Jim Vada on the line today, and he's tuning in from Cincinnati. Is that right, Jim?
Yep, down here in Cincinnati where the sun is shining and it's 67 degrees. So there.
Yeah, well, I moved to Cleveland 3 months ago, and I'm originally from Cincinnati, so I'm a little bit jealous that you're still in the homeland, Jim. I think it's funny, ever since I moved up here, everyone from Cleveland thinks Cincinnati is Southern, which is hilarious to me, because we have Devin who's actually from the South, which,
Woo!
to each his own,
Mm-hmm.
to each his own. But let's see who we got tuning in here. We have Mike working from home in Vancouver. Thank you so much for joining us. We have Paul joining us from Chicago. Let's see, we have Ahmed from Saudi Arabia. Thank you so much for tuning in today. We also have Paul at home in Pennsylvania. Welcome back. And let's see who else we have here. We have Richard, who is joining us from England. Welcome back, Richard. And he's been working from home since March. All right. Thank you guys so much for tuning in, and keep dropping where you're tuning in from in that chat panel. We'd love to hear from you, and we will go ahead and get started. So we are 7Signal, the leader in wireless experience management. And we'll go a little bit more into depth as to what that entails and what our 7Signal mission is in regard to that. Sorry, having some technical issues here. Okay, there we go. So we have an awesome topic here today. We have power over Ethernet and the future of APs with our very special guest, Devin Akin. So Devin, thank you so much for joining us today. And I know we kind of made a joke earlier that regardless of the title, we have a Wi-Fi guy doing a cabling webinar. Is that correct?
That's it.
Awesome. Well, we're really looking forward to it. We have a lot to unpack here. Again, my name is Kelsey Rizzuto. I am a marketing specialist for 7Signal. We also have Jim Vada on the line, who is our director of global Wi-Fi solutions. And we're really excited to really dive in and learn what this topic has and what it entails. So just to start, we have a few announcements. For those of you who have joined us in the past, these will sound familiar. But just to recap, we have a product tour every single Friday at go.7signal.com/tour at 12 noon Eastern. And we'll go ahead and drop that link in the chat here so you can go and register if you're interested. So essentially on these webinars on Wednesdays, we don't really get into the product as much. There's no type of demo. The purpose for today is ultimately to connect with our community of wireless engineers, to educate, to learn about these troubleshooting topics and how to correct connectivity issues. We also have a YouTube channel that we post all of our archived webinars on. So after today's webinar, we'll have our recording up later this afternoon. So you can go check that out at 7Signal and go rewatch some of your favorites and kind of recover some of those insights that we discussed in the past. We also have a Twitter account at 7Signal that we are very active on, and we're going to be posting the slides from today's webinar as we do every single week after today's broadcast. So go ahead and give us a follow, but if you're not active on Twitter, no worries. If you're interested in accessing the slides, just shoot us an email and we can send those over per request. Another reason to follow us on Twitter is because we actually have been giving away a lot of 7Signal merchandise to those who give us a follow and engage with our trivia questions. So I'm going to go ahead and actually read last week's trivia winners. We had a few lucky folks who will be receiving some merch soon. We have first Alan Bediamal, and I apologize if I mispronounce anyone's name, Mike Nakata, and Kimberly Wooden. So congratulations to you three. You should be receiving some merchandise in the mail soon. And for the rest of you, go ahead and give us a follow and stay tuned for today's trivia question. So you can possibly win some 7Signal swag. So a little bit about 7 Signal, just to give you a background, we were established in 2007 in Helsinki, Finland, and we are now located in Cleveland, Ohio. We're really proud of the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. We have over 200 customers, over 30 partners, and 14 patents, constantly innovating in an ever-changing industry. So it essentially goes to show that the technology that you see from 7 Signal, you are only going to see from 7 Signal. In addition, we are certified in over 40 countries, and we're GDPR compliant for our EU folks on the line, which ultimately means that we take privacy very, very seriously. So as I said, for 7 Signal, our mission is in regards to wireless experience management. And what we want to do is to provide a pain-free and seamless digital experience to all of our users so that you can focus on what matters most as opposed to worrying about connectivity issues. We want to keep you productive, connected, and helping others and staying connected to your work. And how we do that is we provide full visibility into the end user experience through an outside-in approach through our platforms of Mobileye and SapphireEye. We're also completely AP and device agnostic, so the current tools and technologies that you already have installed on the system, on the network, are incredibly complementary to what we provide as well. So what we're able to do is to detect the top 7 Wi-Fi problems. Usually when IT is contacted, there is an issue that needs to be resolved quickly, and it typically bubbles up to one of these top 7 problems. We have congestion, coverage loss, co-channel and radio interference, roaming issues, etc. And how we're able to detect those issues is by running active and passive tests on the network, looking for things like packet loss, latency and jitter, adapter and driver issues, etc. Ultimately giving you full visibility and perspective into what is occurring in your wireless network environment. So just to give you a little bit more background on what makes 7 Signal so different, if you look at your typical LAN infrastructure, you've already got great tools, great technologies installed on the network, such as your Riverbed, Cisco, Aruba, providing really reliable data to you that's useful. But what we do is we take it one step further, picking up where they leave off. And how we do that is by providing that outside-in approach that I mentioned earlier. Starting off with Mobileye. Mobileye can give you full visibility into the user experience and ultimately can be installed on any mobile device, from your laptops, your mobile phones, your Zebra scanners, your workstation on wheels, etc. Additionally, it can be installed on any Mac, iOS, Android, or Windows device as well. And branching off of that, we also provide SapphireEye, which are the software-enabled hardware sensors for service-level quality and RF visibility. They're installed up in the rafters, looking down on the whole environment, giving you that really holistic perspective as to what's occurring in your network. Next, what we're able to do is provide that visibility into those external home networks. For example, those great tools, those great technologies that you have on those LAN infrastructures, you're not really using with everything that's going on right now with work from home becoming the new normal. So we're able to give you that visibility into your home networks as well, whether you're working from a multi-tenant apartment, from your home, whether you're trying to find space in the house with all your other users that are also working from home. We give you that full visibility to keep you productive and connected to your work in the midst of all these unprecedented changes as well. And as I said, work from home is the new normal. It's here to stay. And a lot of you joining us on the line live this every single day. For example, we have 76% of remote workers using video conferencing daily, as we're even on a webinar today here. And additionally, 68% of remote workers also have other remote workers in the same household. So what we will aim to do with Mobileye is to provide that reliable insight and perspective into what's occurring in your network in the midst of all of these erratic changes as well. In the midst of that, we have been doing a give back where we are offering a free trial of Mobileye, 50 devices for 50 days, and we'll get you set up quickly. And in regards to that, I will go ahead and drop this link in the chat so you don't have to write this down, and go ahead and check this out for yourself. All right, and with that, we are going to go ahead and launch our trivia question for today. Let's see what we got here. We have Devin gave us a really great question that we're excited to show you all, and I'm going to go ahead and launch that now. All right, are you able to see this poll being distributed?
Yeah, we can see it.
Perfect. All right, well, I'll see a few of you. I see people dropping their answers in the chat right now. I'll give you a few more
Good
seconds.
question.
I'm not known for coming up with hard ones or anything.
Well, you do have to know a little bit about PoE to know this one.
All right, and I will go ahead and close this poll now. Okay, and let's share the results. All right, Devin, how did we do today?
That's pretty amazing. I was expecting it to be terrible, but that's pretty well done. We also have a pretty bright audience today.
I think this is the best the audience has ever done, actually.
And it's not an easy question at all.
Not at all. Particularly using LLDP. Not a lot of people are aware of that.
Right.
Exactly.
Yeah,
right,
so that's why you can use unmanaged and managed switches for PoE with multiple levels of PoE. So because of these two different manners of identifying the PSC capability. That's fantastic.
Well, thank you guys so much for dropping those answers in the chat. Again, we'll be giving away some trivia, so thanks for engaging with us. And while we switch controls over to Devin, I'm going to have Jim give a little bit of an introduction to our special guest today.
Yeah, we're really excited, and thanks, Kelsey. We're really excited to have Devin Akin with us today. If you don't know Devin Akin, and I imagine most of the people on our webinar do, he's been a Wi-Fi evangelist for 15 years. He's an author, he's an educator, he's a consultant. He used to be a road warrior. Not sure that he's still out on the road too much anymore, but his company is Divergent Dynamics. You can find him at divdyne.com. And he's now recently launched his wireless adjuster program, couple-day training to get you up to date with best practices on troubleshooting Wi-Fi with some, pretty, I won't say simple tools, but not the most advanced tools. It's really amazing how much you can do with just a Wi-Fi scanner. So I'm actually looking forward to participating in that training next week, Devin. So happy to have you, and welcome to the webinar.
Thank you. Thank you very much. So if there's anybody in the audience that's ever heard of me, you would know me for Wi-Fi, probably not for cabling or PoE and things like this. So I imagine at least a portion of today's webinar will be a little off center from my normal go-to topics, but they are directly related and hyper important. I'd like to thank Seven Signal for hosting today and putting on this webinar. I think the content is extremely important, not just important to know as in, an academic thing, but more importantly, it's important to know for safety. There's a lot of safety involved here that you might not have considered at all. So let's go ahead and jump in. We're going to talk about PoE, cabling, spectrum, and APs today. Some a little deeper than others. If you want to contact me after, you can email me. My email is listed there, or come to my websites, and then of course on Twitter as well. All right, so we'll start off with PoE and cabling issues, and just first a little bit of facts that you may or may not know, and that will lead into why do we care. So first, there are actually three major categories of power over Ethernet, but there's four types amongst those three categories. The categories, we generally call them PoE, PoE plus, and PoE plus plus, or you could say regular standard PoE, which is 802.3 AF. 802.3 AT is high power PoE, and we've been dealing with those types 1 and 2 for quite some time now. And then of course, today, we now have availability of PoE plus plus, which is very, very high power, and it has two subtypes, type 3 and type 4. Type 3 goes up to 60 watts at the power sourcing equipment, and Type 4 to 90 watts. Now, most of today's switches are the Type 3 variant, but there are already Type 4 switches. Multiple vendors sell Type 4 switches, so it's not like it's some future thing. It's a current thing, no pun intended. But speaking of current, if you'll notice on the Type 4 in the little red box there, you've got maximum current per pair. Now, most everybody in IT knows that data cabling have 4 pair. And so this is on a per pair basis. That's 960 milliamps. That's almost 1 amp. That means that across a cable where all 4 are pulling power, which they are because high power PoE is 4 pair PoE, you're looking at 4 amps, just under 4 amps going across a data cable. Now, you might be thinking, well, that's not that big a deal, but it's a big deal in a lot of ways. Well, the first problem that we're going to run into is that it's still low voltage. So, it's still rated as low voltage, which means, electricians are not involved and certifications are not required in a lot of cases. And so since it's, you're looking at a, nominally 58 volts, in most of the PoE circuits, unless your hands are wet, you're not going to get shocked too bad. But if your hands are wet, you're not going to get shocked. You may get killed. And why is that? Well, it takes about 100 milliamps to defib your heart. And so we're dealing with 4 amps here. And each pair, if you just crossed 1 pair, you're looking at 10 times enough to kill you. So be careful, either wear gloves when you're pulling this much power or have this much power capability on your power sourcing equipment, or make sure your hands are very dry, etc. Don't necessarily stick your tongue to see if it's live across the pairs. That would be a bad idea. And we can see that these 4 types are then further broken down into multiple classes, 0 through 8 here. So we've been dealing with up to class 4 for a long time, power class 4. So that's your PoE Plus that delivers 30 watts at the PSE, the power sourcing equipment. And then at the PD, the powered device, 25.5 watts maximum. We've been using that for a very long time, but now we're starting to move up into the classes 5 through 8. And most specifically, we want to deal with classes 7 and 8, which is the Type 4, because those are the ones that have the potential to do real harm. Now, that's not to say that the 60 watt variant, the Type 3, is not a problem. It certainly can be, but it's not usually as much of a problem, and we're going to see why. Okay, so here's where things get real. Okay, this information came from the TIA spec of TSB 184A. This is the industry standard, global standard, I might add, because TIA is actually an international organization that's accepted, by almost every country. Their spec for cables, temperatures, bundling, conduits, temperature, all that stuff is in this one document. The way the cable is spec'd, and I had to learn this myself after 25 years in IT, when I was updating my CWNA courseware and I wanted to kind of beef up the PoE cabling section a little bit, I discovered a lot of things that worried me a lot. And so I started putting it into the courseware and then making webinars because of the ramifications of this information. The baseline temperature, as far as the TIA goes, is 45 degrees Celsius centigrade. So that's considered maximum ambient. Not that I want to be in a room that is 45 C. That's a very hot room. But as far as cabling goes, they consider that to be the maximum normal room temperature. And most cabling, data cabling, structured data cabling, is rated up to about 60 degrees C. So what does that mean? It means that you've got about a 15 degrees C rise that you can do before things start getting bad, right? Before cable starts melting, catching on fire. Keeping in mind that if the cable is not plenum rated, as it starts to melt, it can release poison gas. And if your plenum area is an air return, this could poison a bunch of people in your building. You do not want your cables to melt. This is bad. You also don't want them to catch on fire. That's bad for a different reason, obviously. So keep in mind that most of your cabling is rated at 60 C maximum temperature. Okay. I've listed a couple of links there of different series of cables from CommScope in particular. I mean, there's a lot of people that make cables out there, so buy whoever you like, but I just use these as an example. These cables are Cat 6A, and they are solid copper, 23 gauge, and they're rated to 105C. This is the kind of cabling that I like to buy and put in my customers' facilities. Now let's look at what the temperature maximums and how that's a problem. If you look at this little kind of bluish, yellowish chart thing here, along the left side, you see the number of cables in a bundle, 1, 7, 19, 37, 61, and so forth. These are kind of standard bundle sizes. And by the way, if I say anything it's a little off or maybe not perfect, I'm not a cabling guy. I'm a Wi-Fi guy who's been studying cabling for the purpose of building better Wi-Fi. So don't judge me too harshly here. But notice the in the top of the chart, it says temperature rise at 1 amp per pair. That 1 amp is rounded. You can see that's coming from the 960 milliamp thing. So let's start at the 26 gauge, 26 AWG there in open air. What we're saying here is when you bundle 37 cables that have 26 gauge copper in them, 37 cables, that 16.2 is above the 15. In other words, the 15 degrees, the temperature rise maximum for your standard cable. So that means it would put it over the limits. The cable would catch on fire, melt, or one or the other or both. So that's the danger zone, right? That's bad. Yellow is bad. If you go to the same kind of cable, but only 19 cables in the bundle, but you put it in conduit, because it acts as an insulator, the heat can't escape, you're down to only 19 and you still, you're at 16.5 there, and you're still exceeding that 15 degrees. So that's how this chart works. When you go to Cat 5E, you can see that, again, the 37 in the conduit and 61 in the open air won't work. Keep going across, and you can see how, with even with Cat 6, you have to watch your bundle sizes, especially in conduit. So bundling is a very common practice. We don't just throw cables in the ceilings necessarily. We group them into bundles where the center cables get very hot, and we have to watch those temperatures of the cables in the center, especially when it's in conduit. Going on over to Cat 6A, notice it's 13.8, 13.4, but that's pretty close, right? That's where it starts to get close to being a problem, and that's even with Cat 6A. So this is showing you that when the cable is too thin and therefore offers much more resistance, or it's the bundle sizes are too big, or it's in conduit, or all of the above, you can start to have a compounded problem to exceed the temperature and therefore get into a safety problem. So this becomes, or will become, a blame game. Now, what do we mean by that? Well, the network engineer is generally not studying cable specs and temperature ranges and things like this. Typically, they're studying access point configuration management systems, things like this. Switching. We're studying a lot of things having to do with protocols and connectivity. But cabling is kind of like, yeah, just get the newest, latest, greatest, Cat 6 or Cat 6A or something. And so cabling kind of gets left out of the equation or left to somebody else, and that's worse. Now, how is that? How is that worse? Well, the cabling guy may be certified. He or she may have a lot of experience. They may know a lot about cabling and even know the TIA specs. But is that enough? It's not, because they don't know what you're going to do with the cable. What are you going to hook to it? How much power are you going to pull over it? What level of PoE, type 3, type 4, etc. They don't know those things because they may not have asked you. And even if they did ask you, you may not know, or you may not know what's coming in the future, 5, 10, 15, 20 years down the road. Cabling is generally installed for it used to be about 25, but nowadays about a 20-year lifespan. So you have to consider, what am I going to put on this cable over the next 20 years? And certainly that's going to be PoE++ type 4 90 watt. That is nearly a guarantee. And so if everybody's pointing their finger at each other, then and your building burns down, people get hurt, people get sued. So this is not just a health problem, or a safety problem, it's a legal problem as well. This is a problem. These two groups, cabling and network engineers, need to be talking and cross-learning. They need to be cross-educated. Very important. So here are some additional charts. These are two different charts here, and if you'll notice on the left one, temperature rise for 48 cable bundle. We just picked a number, 48 cables here, and you've got at the bottom the different types of cable. For example, let's just pick on maybe the purple one. I'll just pick that just for fun. It's a Cat 6A, which you think, oh, Cat 6A, it's latest, greatest, fantastic, except that it's 28 gauge cable. So it may be solid copper or not. It may be rated as Cat 6A, but that doesn't mean it meets the temperature specs for certain bundle sizes in or not in conduit, etc. So notice across the bottom then that you have an amount of current in milliamps. So you can see that with the purple one, when we cross about 750 milliamps, we've crossed the 15 degrees centigrade temperature rise limit. So if the standard 45 plus 15 equals 60 degrees Celsius there, or centigrade, that's where it crosses the line and becomes dangerous. So if you look at the other one, 100 cable bundle, and let's pick a different one, maybe the green one this time. This is a thicker cable. This is Cat 6A, but 26 gauge, which is bigger, solid copper, less resistance, and therefore can carry more current without dissipating so much heat. And so we can make it all the way up to 800 milliamps with this, with 100 cables in the bundle. So what am I saying? I'm saying watch your bundle sizes, watch not just the category, but also whether it's solid copper or stranded copper, also the gauge of the cable. The lower number is better. For example, here we have the blue one on the right side, category 6A, 23 gauge. Notice that even at 1,000 milliamps per pair, and 100 cables in the bundle, you're well under the temperature, and that's because of the gauge of the cable. So when you're buying cable, you're looking for solid copper. 23 gauge is my recommendation, Cat 6A for any cabling in the walls, if you're going to be bundling anything like that, and then rated to at least 90 degrees C. So I would go a little higher even, would be okay. So these are just some examples of how this temperature rise happens with certain kinds of cable in certain bundle sizes. Now you may be thinking to yourself, oh, it'll be years and years before we'll have anything that can pull that kind of power. If you're thinking that, you're wrong. And how do I know that? Because we can already pull this much power. Now there are access points on the market today that can pull that kind of power, that need that kind of power, but not very many of them. Give it 5 years. And we're going to have access points that have multiple 6 gigahertz radios, multiple 5 gigahertz radios, 2.4 USB, multiple multi-gig ports, Bluetooth, BLE, the BLE stuff, and then of course you're going to have LTE, type radios, maybe CBRS and some of those. So these access points are going to become many, multi radios, multiple Ethernet ports, and so on, and they're going to draw all kinds of power. But today, we already draw this kind of power over the cables. We have these things that I like to call extension switches, and I love these things. They're wonderful, but you have to know how to be safe when you deploy them. So for example, you can see this Extreme Networks V300. I love this switch. It's a nice unit. These two ports on the right they power up the switch and all the downlink ports. Those are uplink ports. And you can go to 90 watts each. And Extreme, of course, has, like other vendors, has the Type 4 regular, wire closet switches to power these. So you would run 2 cables. Hopefully, those would be high temperature rated, Cat 6A, 23 gauge, and so on, down to this switch. That power powers this switch, and then you've got 8 downlink ports, and those are capable of 802.3 AT, 30 watts each. And so, if you think about the amount of power, that's 8 times 30, 240 watts. That far exceeds the 180 watts that it can be supplied to this switch. So for that reason, it stands to reason that you could pull a full 90 watts across those source ports, those backhaul ports, and you can. And so you've got to watch your cabling temperatures and types and so on. So this is already happening today, and these allow for some really great design flexibility and so on. But this is just one example of something that can pull that kind of power across an Ethernet cable today. All right, so this slide, I've just done the math for you, and you can see, you know, the 30 watts per port, you know, which could be, you know, 25.5, you know, maximum, you know, as far as the powered device, but even still, that's well more than the 180 watts that it's capable of. So it could completely load both backhaul ports to their maximums. So this is a real situation today. So it's extension switches today, but all these crazy APs later that will have tons and tons of radios, will look a whole lot like a Xeris array, but instead of all Wi-Fi radios, it'll have all kinds of radios and other things, GPUs, CPUs, and so on. You can see here how we're deploying such switches. You take a wiring closet switch that can support you know, type 4, and you know, you dual home it into an extension switch, and then you power up a bunch of APs over it. So that's how this works. And so you need to be considering already today that your cable lifespan is up to 20 years. You need to be thinking 20 years down the road, what's the device power draw going to look like? And it's going to look like, I can tell you already, it's going to look like whatever standards we have. So if we have a 90 watt standard, which we do already, that's what it's going to look like. And it could be worse, but we couldn't possibly tell what that'll be until the time gets here. All right. So this just kind of gives you an increasing scale of, you know, of temperature climb as, you know, power draw, and then of course, as your temperature goes up, you have to shorten your cables as well, because, you know, more resistance. And so it's kind of works both ways. The more power you put over it, the hotter it gets, the higher the resistance. But then the longer the cable, more resistance, the higher the power you have to push, and therefore more heat. So you lose both ways. So just keep it. What I'm trying to drive at here is, when you're using high power PoE, especially if you get into 90 watts, shorten your cable lengths. Don't think that you can push all the way out to 100 meters. You won't be able to. So you'll need to shorten it appropriately. So let's talk about, now that we've scared you adequately on cabling, let's talk about spectrum and where we're going, and we'll tie this together as we get toward the end. So the new spectrum that's coming, that we already have availability to some of it, but you know, the rest of it's coming, is 6 gigahertz and 60 gigahertz. Now you think, well, you know, is this a big deal? Yes, it's a huge deal. And right now, the US is looking at about 1.2 gigahertz. Europe is looking at about 500 megahertz of gained spectrum in the 6 gigahertz ranges, 6 to 7 gigahertz range. And then we have the 60 gigahertz range as well, where we can put up to 6 channels there. These channels are 2.16 gigahertz wide, so the data rates are at peak bonded, or you're looking at about 20 gigabits per second, which is going to be pretty neat, up to about 10 meters, which is also great. Now, like I say, all of this is not available yet, but it's coming. And as we have availability of spectrum, then we have more equipment to use it, more radios in our access points. We'll have 6 gigahertz or dual 6 gigahertz radios in a lot of access points. We'll have 60 gigahertz radios, maybe as many as 3 60 gigahertz radios inside of a single access point. Free space path loss between these radios is so high that you could co-locate 3 radios without any problem within an access point. So this is going to be a big deal as far as how the access points are built, how many radios they have, the data capabilities. When we add 60 gigahertz to the mix, we're going to end up needing multi-gig or even 10 gig backhauls, depending on how many radios we're talking about. Okay. So you can see here in the US, we've got quite a bit of spectrum, 1.2 gigahertz of spectrum, and this is divided up into specific uni bands, all the way from Uni 5 to Uni 8, as you can see, and each have different specs as to how much power and how the power works, and using it indoors versus outdoors and things like this. So this is a lot of new material to learn for Wi-Fi engineers. You won't be able to learn this one all in a webinar, unfortunately, but you can see some here. These graphics are compliments of wirelesslandpros.com, so please go visit their website. And so you can see that we've got multiple bands here, a lot of channels, and then of course the added confusion of channel numbers that we're already using in other other areas in other, 5 gigahertz and 2.4 gigahertz. So that's going to be real fun. If I said, for example, channel 1 in Uni 5, and so is that channel 1 Uni 5 or channel 1 in 2.4 gigahertz? So we're going to have to start clarifying. But there's a lot of spectrum here. If you build it, they will come and they will use it. And we certainly will. The EU gets about 500 megahertz if all goes to plan. So a little bit less than the US, but still a great amount of spectrum. That part's really nice. Here's some things to consider. 6 gigahertz is an 11AX greenfield opportunity. That is wonderful. No backwards compatibility considerations with legacy devices that are going to slow everything down. That's a great thing. Regular use of wider channels initially. In other words, some folks will run out and think that it's going to be okay to use 160 megahertz wide channels. And it will be as long as nobody's using them, but they will use them. And so eventually and very quickly, people will come back down to 80 megahertz. And so, that's, you're going to find that it's going to be very common to see 80 megahertz out channels out there. Of course, there's only so much spectrum, so it'll get busy quick. And then you have to consider, if it gets busy, what do we do? Well, we come back down to 40 megahertz and then 20 megahertz and so on. But the good part is that it gives us time. It's enough spectrum to give us time. Now, there's another good aspect of this 6 gigahertz, and that is that the power maximums are calculated on power spectral density within the FCC, at least. Don't know about Europe yet, which is good, which means we don't have to worry about the SNR decreasing as we widen the channel, because the noise floor, the way this works is the noise floor rises 3 dB every time you double your channel width. And so in this case, they're going to allow us, the FCC is going to allow us to boost the output power to offset that loss in SNR. So that's fantastic. So that makes wider channels a little more viable for us. But again, the spectrum will get busy quickly. So initially the spectrum will be clean, but if you build it, people will use it. And the more they use it, the busier it gets, and the more OBSS conditions or the more CCI and things like this you're going to have, and then you'll end up going back down to 40s and then 20s and so on over time. Okay. Now, one of the good things about 6 gig, since it's greenfield, is it's only going to be 11AX devices, at least initially. And so, we don't know what other 6 gigahertz capable technologies are going to appear at, over the horizon here. But right now, the 11AX, that is, being able to subdivide your channels into RUs and serve lots of clients, that's going to be a greenfield thing for a while. That's going to be good. A bad thing is that the 802.11 protocol is unchanged for 6 gigahertz, which means it still has all that high overhead of legacy physical layers, and there's not a lot we can do about that, and the IEEE is not about to spend the resources to rewrite the entire protocol for 6 gigahertz. I get asked a lot, well, how long before 6 gigahertz is useful? I mean, well, we can use 11AX as an example of this. 11AX has been hyped and hyped for a long time, and yet even today, most people don't use it. They turn off those features. It's because of availability of clients and maturity of drivers and things like that. Well, when it comes to spectrum, it works kind of the same way. I've kind of done a left to right life cycle here for 6 gigahertz. And you can see in the beginning, on day one, it's all marketing, it's vaporware. You do announcements on infrastructure you don't have. And then eventually, 6 months out, maybe you get your first generation chipsets. Sometimes they're defective, as we've seen with 11AX. Sometimes the chipsets are incomplete, like we've seen with 11AX, and the software is buggy, like we see with every kind of software within the first 6 months. The first infrastructure products become available in about the 6-month point, but some early adopters buy them. Good luck. Most people avoid them. Less than 1% at the 12-month point of enterprise clients support the new physical layer. So after a year after the announcement, so some vendor comes out and says, we have 6 gigahertz. If you wait a year, then you'll have less than 1% of your enterprise that's going to support that 6 gigahertz. So that should give you an idea that you are wasting your money in the first year. The first mainstream clients become available after about a year. That's why. Okay, you push on out 18 months. You know, it's going to give you very little benefit, even with a small percentage of clients. It gives you very little benefit. You know, you're going to have an operational system with kind of a small subset of physical layer features. In other words, you know, the marketing comes out and says, we've got these 10 advantages. Well, you might be able to count on 3 of them, sort of, right? And it's only going to be available on some clients. Well, then some time goes by. Let's call it from the 18-month to 5-year standpoint. And now, finally, after 5 years, which is an entire life cycle of products, a full life cycle, you've got anywhere from 30 to 50%, depending on the vertical market you're in, education or warehousing. And, you know, some markets are early adopters, some are not. Of your client devices are supporting the new frequencies and features. And that, so a third to a half, depending on your market, after 5 full years. So that is happening right now with 11AX. We're seeing the same thing. So there's no reason to believe that 6 gigahertz can be any different other than just marketing hype. And so the best practices are regularly violated at the 5-year point. People still don't know how to deploy it properly. And that, of course, is going to hinder your capacity or performance. There's only a few of the physical layer features that actually made it into products. You know, instead of the 10 that were hyped, you might have 3. And maybe you get those 3 certified by the Wi-Fi Alliance. Okay, maybe. Everyone is realizing that the physical layer was overhyped and underdelivered after 5 years. Think back through 11AX, 11AC Wave 2, Wave 1, 11N, and so on. It has been this way every single time with every single PHY since the beginning. After 10 years, 50 to 80%, you're still not at 100% saturation. Half to maybe 80% of your depending on your vertical market of your client devices support these new features. So give us 10 years and we'll be somewhere between, call it, you know, half and 3/4 of the market will finally be 6 gig capable. 10 years, that's 2 full product life cycles. And then, of course, by the point 10 years gets here, nobody cares. They've been hearing 6 gigahertz for 10 years. And so there will be more and other marketable physical layer technologies, and everybody will be hyping that. And, you know, there'll be, you know, 10 gigahertz or, you know, or 11, you know, AZ or whatever it is, the new kid on the block. That will be what the big deal is. And nobody's going to think anything about 6 gigahertz, but it takes a long, long time to get to that point. So just keep in mind, the bottom line of all this is no matter how fast infrastructure vendors get 6 gigahertz radios into the market, the usefulness of them is solely, this is on the infrastructure side, the usefulness of that infrastructure solely depends on the client device availability. Very important. We've seen that with 11AX already. Okay. So what about 11AX and 6 gigahertz? Well, it's going to require additional radios in the AP, right? That's a given. It's going to require 6 gigahertz capable clients, and it's going to make availability of wide channels there for a while. You know, we'll have some clean spectrum. We'll be able to use 40 and 80 megahertz channels pretty regularly and cleanly, and that'll be great. And the initial hit will be wonderful once you have clients that can do it. But of course, over time, the contention on those channels will go up, just like it has in 5 gigahertz. You know, wasn't very long ago we were talking about how 5 gigahertz is the way to go. It's clean spectrum, it's wonderful, blah blah blah. Now there are places that I go where all the channels in 5 gigahertz are highly utilized, which is especially in high density environments like stadiums and arenas and stuff like that. You know, more channels is better. Chipset manufacturers already production ready with your first gen chipsets, as I'm told. I don't have any special information there other than what I'm told. So production ready stuff is already there for the chipsets. Of course, the access point vendors are not finished building access points yet. So there's going to be a variety of 6 gigahertz capable AP configuration possibilities, whether it's dual 6s or radios that are 5/6 switchable and things like this. There's going to be a lot of different variety in the market. You know, when you have 2.4, 5, 6, and the capability of adding sensors and dual 6s or dual 5s and dual 6s, you can get into some pretty interesting scenarios that pull a lot of power, by the way. What about 60 gigahertz? Well, 60 gigahertz is not something we talk about all the time. We call this Y-gig. This is some pretty amazing technology to me. Up to 6 channels, we're dealing with a range from about 57 to 70 gigahertz. And depending on which region you're in, will determine how many channels you're allowed to use. These channels are 2.16 gigahertz wide. They are very, very wide. So the data rates are crazy. Well, how crazy are we talking? Well, 20 gigabits or more. Actually, if you're bonding, multiple channels, you can bond up to 4 at a time. So your data rates can get to be ridiculous on the peak side. But of course, it still has duplex, and we've got limited range. Most of the time, you're going to find that due to free space path loss, that WiGig is going to be useful up to about 10 meters, preferably 8 or less. But that's a pretty large room. It does support transmit beamforming bidirectionally, and you can, of course, it's going to use the environment to bounce signals around to optimize, just like transmit beamforming does. It uses OFDM, and MIMO technology, which is really nice. 11AD, its predecessor, did not use MIMO technology, only OFDM, but now we have both, and MIMO is wonderful stuff, as you already know. We also know that in a half duplex radio environment that your typical efficiency is about 45%. So whatever your data rate is, multiply times 45%, and that's what you could expect with a single client moving traffic in a single direction. That's, and of course it goes down from there as contention goes up. Okay, this could be useful for RTLS technology, the real-time location services, because we will know for sure that the device is in a room, because 60 gigahertz frequency ranges do not go through drywall or anything else much. It might go through some glass, but not much of anything else. The wavelength is just absolutely tiny. The output power on these, even on the client devices, generally around 10 dBm of actual power, and then we use high gain antennas in order to be able to offset the free space path loss, which is quite nice. The FCC allows us up to 33 dBi. That's a majorly high gain antenna on a very small device. So the EIRP can actually go up to 43 dBm, which is just crazy. Okay. Now, when's this stuff due out? Shortly, as you can see in the screen, December of this year is the target for WiGig or 11AY as a standard to be released. And even if it's a month or two late, who cares? The technology is pretty much done. So I believe this is the kind of next big thing, because it provides very, very high throughput, multiple radio capability. And so you're dealing with an edge solution that is super fast. You basically have more throughput than you can even use at the edge. So given 6 gigahertz and 60 gigahertz, all this new spectrum and new possibilities and all this, what happens to our legacy spectrum? Well, it isn't going anywhere. And so 5 gigahertz is going to be around for a long, long time. And 5 gigahertz and 6 gigahertz are designed to coexist. The discovery for 6 gigahertz, considering there's so many channels, instead of doing standard discovery where we're probing and whether it's passive scanning or active scanning, we're not going to be doing it that way generally. It would just take too long. So instead of that, we would do that on 5 gigahertz, querying the APs to say, what do you support on 6 gigahertz? So the discovery will happen on 5 gigahertz in order to find the 6 gigahertz channels. So you're going to see a lot of, or most APs are going to co-locate 5 and 6 gigahertz radios on access points. What about 2.4 gigahertz? Here's what I think. I think 5 and 6 gigahertz will be used for standard Wi-Fi for a very, very long time. 5 gigahertz will become a junk band over a long period of time. 6 gigahertz will be our main spectrum for a while. Then 60 gigahertz will be our main spectrum, and eventually 6 gigahertz will become junk band. But that's many years in the future. But 5 gigahertz could become a junk band nearly overnight. Call it 5 years. 2.4 already is. 2.4 gig is not a great place for Wi-Fi. Do we still use it there? Of course we do, worldwide. Does it work? It works in some places, not in others. There's so many devices, whether it's legacy 11B and G and all that, or IoT devices, BLE, various types of Bluetooth, and anything else. Remembering that it was a industrial, scientific, medical band, which means it was all kind of garbage in it even before we started using Wi-Fi back in 1997. So yes, 97 if you're wrinkling your eyebrow at me. So, the 2.4 gig spectrum is already kind of a lost cause that nobody should be putting mission critical stuff into. So my suggestion here, and what I think is going to happen, is that 2.4 gig will become an IoT or a wasteland for things that are more resilient than Wi-Fi, and Wi-Fi devices will move over into the 5 and 6 almost exclusively over time. And that'll happen when people get sick and tired of it being terrible. Okay, you know, it'll go at whatever pace the person's willing to tolerate. Well, what about access points? I mentioned in the title, we're going to talk about the future of access points. Okay, here we go. The next generation of access points, and I hate to say it, but they're going to look a lot physically like Xeris. If you're not familiar with Xeris, they made flying saucers, they made spaceships, modular access points with big CPUs, pulled lots of power, lots of backhaul, 10 gig or multiple multi-gig pipes, et cetera, et cetera. They had one thing right, and that is a big disk with lots of radios. They had one thing very wrong, but it wasn't really their fault. And that is they had all Wi-Fi. It was 5 gig, 5 gig, 5 gig, 5 gig, 2.4, and so on. But that's not the future of Wi-Fi. The future is to take this big access point, whether it's modular or it isn't, makes no difference. And we're going to put all kinds of things in it. It could be things like 2.4 gigahertz, 5, 6 gigahertz, 60 gigahertz, Zigbee, BLE, CBRS, and things like this. And multiples of each, by the way, sensor radios and such as that, you know, and multiple 6 gig and multiple 60 gig. But then there's other things that you can put in there, things like ultra wideband, speakers. I mean, right now Ubiquiti has a speaker in one of their access points. Cameras, Extreme Networks has a camera in one of their access points. You know, 5 gigs cellular, not just CBRS, but regular cellular networks could be put in there. Security scanners that covered multiple security scanners depending on frequencies, and then even microservices where the AP becomes, you know, an endpoint for a variety of testing. It could be a server. It can serve as a, you know, whether it's iPerf or something like that, or even a sniffer. The access point runs Wireshark right there in an instance on the access point, and then you can just pull it off of TFTP or what have you, your capture. So all of these things are currently in the works or already exist. All that doesn't exist is putting them all in the same access point. And so that's where, with all of these options, we're going to find that vendors start to become very creative in serving vertical markets and saying this market needs this, and this market needs that, and so on. And they'll build APs with the appropriate components. So some of the questions you should ask are, you know, in understanding that this is going forward, this is how it's going to go forward, is things like limited ceiling space. My friend Chuck Lukashevsky, one time we're at a conference, and he said Aruba, at that time it wasn't HPE, he said Aruba has already calculated all of the square footage or ceiling square footage in the world, and so we know the size of the market. And so that caught me a little off guard, that anybody would take the time to calculate all the ceiling space in the world. And how they figured that out, I don't know. But that is a concern because there are lights and you know, and air vents and sprinklers and all kinds of things. So you can't just put infinite numbers of access points, radios, and things like that on the ceiling. So we're going to have to consolidate them. Whether they're modular or not, again, is a vendor's choice. Will the access points address IoT? They'll certainly have to at some point. You know, the vertical markets, you know, there's just, you know, how much money do you want to spend on an access point? Do you need a GPU in order to keep up? I mean, the kind of throughput that you'll get with a 60 gigahertz is insane. So multiple backhaul ports, it could be multi 10 gig or multi 5 gig, et cetera, pulling multiple 90-watt sources. So you have to watch your cabling and so on and so on. So this can get to be a little bit crazy if you think about it. Here are some different innovation options. This is just me thinking kind of out of the box. Nobody's building this that I know of, but this is just the kind of thing to consider, the directions it can go. Consider that we've got access points out there already today that have 5 gigahertz and 2.4 gigahertz, maybe multiple 5 gigahertz and so on. Maybe we don't want to, you know, buy an access point and replace all the stuff that's already working. We just want to add to it. So maybe we just buy, triple 11AY radio access points and put those on the ceiling beside the ones that we have. Or maybe, we complement what we already have with a 6 gigahertz, 60 gigahertz combination access points. And all of that could be fed out of extension switches that are basically laying in the ceiling. So they're powering multiple APs right there locally over a pair of PoE++ backhauls into the wiring closets. So there's a lot of different ways to innovate at the edge. And of course, vendors will be thinking about how can we sell switches? How can we, sell access points without asking the customer to rip and replace? How can we complement what they already have? And things like this. So there's a lot of different ways to innovate now that we have 6 and 60 gigahertz and PoE++ type 4 at our disposal. So with that, I will throw it back to Jim and see if he has any questions.
All right. Thanks, Devin. That was really awesome. And want to invite everybody to put questions in the Q&A pane. I think we have time for a couple questions. Lawrence starts us off. He says regarding the cabling portion, he says, are bundle sizes based on the highest number in a bundle at any point? What I'm thinking is at the closet end of the cable, at the closet end where the cable installers are pulling everything out, a few locations, but as they spread out, the bundles will be smaller as they follow the path.
Yeah, so you have to consider multiple things there. First is the largest size of the bundle anywhere in the cable run, because the cable could catch on fire or melt anywhere along the run. Secondly, you have to consider the areas through which the bundles go. In other words, if they're in an attic that's already 140 degrees, Fahrenheit, or whatever Celsius that is, hot. Let's just call it hot. You've got attics that are very, very hot. They're very dry, and you've got the cable going through that section in a bundle of 19 or something like that. Even if it's just for a short distance, it doesn't take but a short distance for the cable to overheat. And once it starts melting or catches on fire, everything around it's going to catch on fire. So it's not just bundle sizes or conduit, it's also where the cable is routed and what the temperatures are in those areas maximum.
Gotcha.
Keep in mind that, the cables themselves don't actually have to catch on fire or melt to catch other things around them on fire. When you have, whether it be, attic areas, something like that, that has a lot of dry wood or dry, boxes are being stored, things like this, if it becomes very, very hot, the cable itself may not have the problem. It may cause the problem because of something that's sitting on the cable or next to the cable.
All right. Peter asks, what do you think about light communications for wireless LANs, sometimes called Li-Fi? When will it get on the market?
Yeah, so that technology has been available for quite a long time, but not commercialized because the commercial aspects of it are just not there. The throughputs, last I checked, the throughputs they were getting was around 50 megs and at peak, and that's just not good enough in comparison to especially comparison to the 60 gigahertz technologies we're dealing with, which are, you're dealing with, peaks of 20 gigabits per second. So, with wide channels in 6 gigahertz, you're still talking about, over a gig of throughput capability. So those technologies are just too limited and not commercially viable in most markets, so I don't think you're going to see much from that technology in the near future unless it is vastly improved over where it is now.
Yeah, and I think so far it's all been proprietary solutions.
Yes, that's right.
Although the 802 has an 802.11bb task group that's looking at light for wireless LANs. So keep an eye on that. I think maybe one more question from Stephen. He says, so realistically, as per CWNP comments, we are realistically looking at 5 years before the need for 802.11bz, I think he means 802.3bz, mgig, or higher density campus LANs.
So I'm going to try to, I don't want to really tread carefully. That's not what I'm after, but I want to speak plainly about this. current, let's just talk, rather than talk about future technologies, let's talk about where we're at. 11AX is the latest, greatest physical layer. And we are not going to go over a gig on 11AX anytime soon. And there might be somebody out there going, no, I can make it happen, man. You can make it happen if you're using one client that is a 3x3, which, we don't generally deal with 4x4 clients. 3x3, uplink only, UDP only, perfectly clean channel, 80 megahertz. You can get just over a gig. That's not real world. That's pushing about 85 to 90% efficiency, and normal Wi-Fi operates at about 45% efficiency, best case, in a normal world. We have multiple clients. We don't use 80 meg channels generally. We use TCP and UDP both. We have clients that are moving. Not all clients are at the maximum data rate. There's a whole bunch of variables there. And so your average throughput peak, I'm talking absolute peak on an average enterprise, is about 50 megs. 50 megs. And you're thinking, no, that's not true. I can prove it absolutely that 50 megs is your average peak on most networks, because of the client capabilities being a mixture of 1x1s and 2x2s, regardless of what your AP is capable of. And so if you're talking 50 megs and we've already got gig capability, how long before we need multi-gig? So I'll tell you when. 6 gigahertz. And so once we get to 6 gigahertz, somebody's going to be using 80 megahertz. And again, with 80 megahertz channel, UDP, et cetera, you can get just over a gig. But again, that's not real world. You won't actually get a gig in real world till you hit 160 meg wide channels. And even then, it would have to be very few clients. So we're a long ways from needing multi-gig. Vendors build it because other vendors build it. One vendor wants a leg up, so they build it, put it in their spec sheet, and then every other vendor builds it to keep up with the Joneses. 60 gigahertz is when we'll need it. Once we have 60 gigahertz capability, one or more radios, even one's fine, you will need multi-gig backhaul. It will be a big bottleneck if you don't. So that's what I'm gauging it on in my designs, is show me the 60 gigahertz and I'll show you the multi-gig.
All right. Thank you, Devin and Jim. I think that's the last question that we have time for. Thank you, Devin, so much for being our special guest today on this episode of our Best Practices webinar. We've really loved having you. We've got some great comments and questions that people have asked. And thank you all for tuning in today. So have a great rest of your week, and we hope to see you at next week's webinar.
Thanks, Devin. That was awesome.
Thank you all. Have a great day.